Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, and sometimes about software engineering in general. If you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to talk about this Go library that can be used to talk to a Kubernetes cluster. So if we talk about an ideal scenario where we have a Kubernetes cluster set up and running, and someone wants to talk to this Kubernetes cluster, they can use kubectl command line tool to talk to this particular Kubernetes cluster. And this way is mostly used by developers and administrators who want to access the API server or Kubernetes cluster to do certain things. But there are cases where we would want to write an application, a program that is going to interact or communicate with Kubernetes cluster to do certain things. For example, let's say we want to write an application that is going to get us all the pods from a specific namespace. Obviously we don't have a real use case for this particular program, but this is just an example. So let's say if you want to write that application, in that case these libraries that Kubernetes community or Kubernetes maintainers provide can be used to do all those things or to interact with all these API resources that Kubernetes server has. When I talk about API resources, I mean the resources that are registered in the Kubernetes cluster. For example, pods, services, deployments, stateful sets, etc. If we talk about so the if we talk about accessing Kubernetes cluster, we basically use set of libraries, not just one. Client Go is the main one, I would say, but there are some other client libraries, and using these libraries, we can very easily talk to Kubernetes cluster to do a lot of things with these API resources. When I say a lot of things, I mean we can perform any operation using the exposed HTTP verbs. For example, get, list, post, patch, put, and delete. Now, if we look into what are all these libraries that are useful to talk to Kubernetes cluster, there are three main libraries. And first one, as we discussed about, is client Go. Another one another one one is a library that provides all the API types. And the third one, so this is first one, this is second one, and the third one is API machinery. And we are going to look into these in a bit, but all these libraries can be included in your Go project using the module k8s.io slash client go, and any module from client go library. Similarly, API can be used by importing k8s.io slash API, and similarly API machinery. Now, if we talk about the responsibility of these libraries, if we start with client go, so client go actually exposes all the interfaces that can be used by client to interact or do certain things with the Kubernetes API server. So for example, if I just go ahead and have a look into this client Go, this is where the source code of client Go library is. And this entire library is useful, but we can basically look into these two directories, that are tools and another one is Kubernetes. So if we look into tools from client Go library, this particular library can be used to create client set and some other things. And if we look into, for example, Kubernetes, we can see that all the types are all the types are I would say, exposed here, or their interfaces are exposed here. For example, if we want to look into all the things that a client can do using this particular library, and if that resource is in core v1 namespace, core v1 group, and for example pod.go, we can see that all these methods can be called by a client that is using this library to do certain things for pod resources that resides in core v1 API group. So I think that should make sense if I try to explain it once again. If we talk about client go library can be imported in your project using kates.io slash client go, and this particular library exposes some interfaces that can be used by client to interact with Kubernetes API server. Now, if we talk about the other library that we talked about, that is API. So for example, let's say if we talk about the resources, Kubernetes resources, pods, deployments, stateful sets, and other Kubernetes resources, all those resources are are maintained or exposed, not exposed, all those types are, I would say, maintained in API library. And again, this can be accessed by visiting Kubernetes and API. So here we go. We can see that for every API version, we can see the details. So for example, if we go to core v1, we would be able to see the API types that are inside core v1. So for example, if I go to types.go, I should be able to see all the types or all the resources that are inside that are part of core v1 API group. So if we click on types.go, we should be able to see. So for example, if we talk about volume is part of core v1 API group, and that is the reason we are able to see volume in this particular source file. If you remember, pod is also part of core v1 API group. So if we just search for pod, we should be able to see pod as well. So yeah, now that we have discussed about client go API, and the third most used library, I would say, while developing Kubernetes native application is API machinery. So API machinery contains some common code, or some code that can be used by anyone, I would say, not just while developing Kubernetes applications, but while developing any Kubernetes like API, because it has a lot of utility methods. We can say, very basically, we can say that it has a lot of utility methods that can be used to develop an API. For example, let's say if we just go ahead and again we should be able to see that for inside Kubernetes organization. And here we go. Again, this can be imported in your Go project using kates.io slash API machinery, and this has a lot of utility methods, I would say. For example, let's say when we try to list all the pods, we will also have to, or we can also specify some kind of filter for the list of pods that is going to be returned, and all those filters, all those things are specified in API machinery. So now that we know what are all the libraries that we are going to use to interact with Kubernetes API server, let's just go ahead and try to write a very basic program that is going to get us all the pods from let's say default namespace. So okay, let's first initialize a Go project. First of all, this video requires an intermediate level of knowledge of Go programming language. So if you are not aware about Go, maybe you can continue watching, but there are chances that you would not understand some things. So just let me know about them in comment section, and we can discuss about them in there. So I'm just going to initialize a Go project. Let's say named project one. And once this project is initialized, let me open that in my editor. I just have created a source file named main.go, and let's write a function main. And from this main function, we want to talk to Kubernetes API server using these client libraries, but we will have to somehow specify where our kubeconfig file is. Otherwise we will not be able to access the Kubernetes cluster, because we know that Kubernetes cluster is secured, or secured by some authentication mechanism. If we just try to talk to that API server without providing any details, any credentials, we will not be able to access that. And we also know that kubeconfig file contains all the details about a Kubernetes cluster. So while using these libraries, we can specify kubeconfig file, and using kubeconfig file, these libraries would be able to figure out which particular cluster they have to talk to, and things like that, and what kind of permission they have. So first of all, what we are going to do is we are going to get, let's say kubeconfig file as an argument to this particular program. So this is a very simple Go program, let's say, and we want to use flag module, and this program is going to expect a flag named kubeconfig. If the value is not provided, the default is going to be kubeconfig, and we know that the default location of kubeconfig file is home.kube and config. That is the reason we have specified the default value to be home.kube and config, and this is location to your kubeconfig file, and let's store it in kubeconfig. Now that we have kubeconfig file, what we can do is we can import the client Go library that we talked about, and we can create a client to actually talk to Kubernetes API server. So let's just go ahead and try to import that. Now if you want to look into some examples, client Go also gives us some examples in this particular directory. So if you go to examples, you would be able to see all these examples here. So we are going to import gates.io / client go / tools and client CMD, because this is what we talked about when we looked into client CMD. So all the resource methods are exposed in Kubernetes directory, but all the other related tools are in tools client CMD. And we can use client CMD dot build config from flags, and we will have to give it the kubeconfig file, and it is going to get us a well-formed config file. Now let's just go ahead and try to build it, just to see if you are able to do the things right, if you are able to build this particular program. If error is not equals to nil, in that case we will have to handle error somehow. Okay, let's just go ahead and try to build this. I hope this make sense, if any of this source file doesn't make sense to you, just let me know in the comment section. Maybe I'll be able to explain them there. So here we can see that it says there is a mismatch between the definition of what we are expecting and what we are providing. So now there is this important thing that comes into picture that I want to talk about. So for example, let's say the client library that you are using and the things that are available on your cluster are to separate things. So for example, if we, let's say this is our Kubernetes cluster, and in Kubernetes cluster there is a resource named pod. Let's assume this is just an example, and this pod has some fields 1, 2, 3, and 4. Now let's say this is Kubernetes version x.y.z, and now we are using client Go, and this client Go has the same resource, I would say, but this particular client Go is stale. Version of this client Go is stale and uh, is not, I would say, compatible to your Kubernetes cluster. In that case, there are chances that this fourth field or any of these fields is not available for the pod resource in the client Go. In that case, things are not compatible, as you can see here, because if you see pod resource in your client has some other details, and pod resource in your server Kubernetes cluster has some other fields, and this is a compatibility issue that arises sometimes, and it can be resolved by looking at this particular compatibility matrix that we see here. So it simply means, for example, if we talk about Kubernetes 1.1.20, this particular check mark means that if we use client Go library version this, it simply means that all the things that are there in the Kubernetes cluster would be available in the client Go as well. So this is what it means. Exactly the same features, API objects in both client Go and the Kubernetes version. I hope this makes sense. For example, if you are on Kubernetes 1.19, it's recommended that you use this particular client Go version. So, and this is the reason that we talked about. For example, there are chances that if you are too far from the Kubernetes cluster version, or if your client Go version is too away from your Kubernetes cluster version, there are chances that there would be non-compatible things, and that is the reason we should refer to that compatibility matrix to figure out which particular client Go version we should be using. So let's just go ahead and look into which particular client Go version we are using right now. So if we go to go.mod, we can see here that we are using client Go version this, and our Kubernetes cluster version, we have Kubernetes cluster version 1.12. So it's better if we look into this metrics once again. For Kubernetes 1.20, this is the version that should be used. So let's just go ahead and try to download that specific version, and we can do that by using go get and then library name. Library name is gates.io client Go, and then version name is, again, we can get that from here. And if you can see here, this is downloading this newer version of client Go library, and as you can see here, this client Go library has been updated now. If we just go ahead and try to build this project once again, we should be, yeah, at least we don't see the error that we saw earlier, and it says Okay, so I hope this makes sense. Now that we have cube config file or well formed cube config file, we can use another another I would say call to actually create client set using this particular config file, and that can be done using this particular module, that is client go and kubernetes dot, I think it's new for config, but let's just go ahead and try to refer the example here. So, alright, so we have config and we can use kubernetes dot new for config, and we can give it config. It is going to get us client cmd, and if there are any errors, again we'll have to check if the error is not null. In that case, we'll have to somehow handle the error. I'm just printing these things out just to make sure that Go should not complain about these things. Somehow auto Go def doesn't seem to work. Okay, it looks like some network issue. Just a second. So let's just go ahead and try to change the version of API library that is being imported here to 22, and because that is the version that we are using for client Go, let's save it and run Go build again to check if things are working. Once this is built successfully, we can talk about what is what is client set, and how we can use it to do things with Kubernetes cluster. Okay, meanwhile it is being built. If we talk about this particular value here, this is a client set. We call it a client set because it is set of clients that can be used to interact with the resources from different API versions. So for example, let's say if you want to list, let's say, pod resources, you know that pod resources are from core v1 API version. You can call core v1 from client set to actually get, list, delete, or update pod resources. Similarly, if you want to interact with, let's assume, deployment resources, in that case, if you know that, I mean, you should know that deployment resources are from apps v1 API version. In that case, you can call apps v1 from for client side to actually interact with deployment resources. And as you can see here, this has been built successfully. Now let's just go ahead and try to, our motive is to get all the pods from default namespace. So client side dot core v1, as I said, you will have to know, or you should know the API version of the resource that you want to interact with. In our case, we want to interact with pod resources, so we should know that pods are from core v1 API version. Dot, we want to interact with pods and we want to list pods, let's assume. Now this is all I actually need to list all the pods from a specific namespace. Now the namespace can be specified for pods, and for example, for as of now, we just want to specify default. If I just go ahead and try to run this should not work, and the reason is, again, handle error somehow. Because I think list expects a context and list options. So if I go build again, and when I, yeah, here we go. So it expects context and list options. So we can create a context here, and we will have to also specify list options, and that is where API machinery comes into picture. As you see here, list options should be from API machinery. So let's just go ahead and try to import that, and let's name it meta v1, and we can call it meta v1 and list options. I think this should at least get built, and once it is, okay, it is somehow still not saved. It should be built now, and as soon as it is built, if I run the program, we should be able to get all the pods. Now okay, so it looks like we are accessing something that is nil, and that is the reason we are seeing invalid memory address here. It looks like we are not getting config correctly. So let's go ahead and try to pass cube config file. Let's see, maybe it was not able to resolve that tilde operator. Let's see if this works. Okay, here we go. So initially it didn't work because we used this operator to indicate our home, but it looks like it was not able to resolve that operator. So home Vivek, and it looks like now things are working. So if we look into the official documentation of how this response looks like, so okay, this is what I was expecting. So it returns, if you see here, it returns pod list, and inside pod list we have items that contains a slice of pods. So what we can do is we can say for underscore comma pod colon equals to range pods dot items, and now it simply says that we have pod, and we can list print ln or print f pod name, or let's say pods from default namespace, and let's just print them here. Pod dot, we just want to print name of the pods. So if we go ahead and build this once again and try to run this again, it is going to get us all the pods from the pod namespace. So dot slash project1, and we can say here we didn't get any pods listed because we don't have any pods in the default namespace. So let's just go ahead and try to create a dummy pod just to check that pod gets listed using our program. So kubectl run nginx hyphen image nginx namespace default, and run. Okay, it looks like I'm using updated version of kubectl command line. So kubectl create deployment nginx hyphen image nginx, it should work. And now we have a pod in default namespace. Now our application should also return the same pod, and as you can see here, we are getting the same pod name. So yeah, I mean, this is how we can use these set of libraries that are client go API machinery as well as API. We have not used API yet, and we can use all these libraries to actually write an application. For example, this application that is going to talk to a Kubernetes cluster to do certain things. Now we were having some issues over here. If I want to explain that once again, so we expect this application to have a flag named -kubeconfig. If we are not specifying that flag, value of that flag should be this particular file, and that is how this particular config is being formed. So we can say that using client cmd.build config from flags, we are parsing the kube config file, and then we are storing the result in this particular variable, and then we are creating client set, and using client set we can access all the resources that we want to interact with. Now let's assume we want to get all the deployments from the default namespace. So what we'll have to do is we'll have to just extend it somewhat like this. So client set, and we know that deployments are part of apps v1. So apps v1 dot deployments from namespace default dot list, and again it is going to expect context. So context and meta v1 dot list options. Yeah, and again this returns deployments list, and that has items. So what we can do is for underscore comma deployment colon equals to range deployments dot items, and here we go. If we go ahead and build this application and then run it again, we should be able to see deployment listed as well. So project1, and here we go. So this is pod, and deployments, or this is deployment. So I hope this makes sense. If you have any question, any issues about this, just let me know in the comment section, and I would be happy to answer them for you. Now I'm not saying this is how you are going to write your production level code. This is how production level codes are written. But this gives you an idea of how you can use these libraries to write an application that can be used to talk to your Kubernetes cluster. For example, I think can we can have a better way to get kubeconfig, or we will have to, I think we are not calling flag.parse here. That is another issue. We can have these namespaces as a constant, or we can have them from users and things like that. So I think I think you understand that. Now if I want to, if I want to discuss, for example, let's say this is our Kubernetes cluster, and what's happening as of now is we have this host machine, my client machine host, and this project one is being run from here, project one. And project one is actually trying to figure out, project one figures out details about this Kubernetes cluster using kubeconfig file that we are specifying in the program here. Now let's assume you have to run this entire program or application on Kubernetes cluster. In that case, you wouldn't have access to this kubeconfig file. So in that case, your program should handle that. So your program should check if you are if you are in inside Kubernetes cluster, or if this particular program, if this particular program is being deployed inside Kubernetes cluster. In that way, figure out the things to talk to, figure out the details about Kubernetes cluster using another way. Or if you are running outside Kubernetes cluster, then try to use kubeconfig file to talk to Kubernetes cluster. So there are two ways. Either we are running inside Kubernetes cluster, or we are running outside Kubernetes cluster. So in case of outside Kubernetes, if we are running from outside Kubernetes cluster, we have seen an example. We can either specify kubeconfig file while running the program, or we can write code in such a way that it can try to figure out kubeconfig file from this, as you can see here, default kubeconfig path. Now if we are running inside cluster, we can use this another mechanism to create client inside Kubernetes cluster that we are going to look into in next videos. So let me just check if there is another thing that I wanted to talk about. Yeah. So, for example, I think we have already discussed about that in one of my previous videos, but I can summarize that once again maybe. So we know that any Kubernetes resource can, or let's say group, can be in multiple versions. So for example, let's say if you talk about deployments, they were earlier in extensions, and they were migrated to apps group, but they earlier were in extensions. Similarly, the groups can also be in multiple versions. So for example, just an example, if for example apps was earlier in v1, then v1 beta 1, and then it was promoted to v1. So what I'm trying to say is, even though if your resource is created through a separate version, for example, uh, let's say if we are talking about deployments, and your deployment was created using v1 v1 beta 1, and this deployment resource is also available using version v1. In that case, even though the resource was created using v1 beta 1, it can be accessed by v1 as well, using v1 version as well. And this conversion from v1 beta 1 to v1 happens on the fly using the libraries that we are going to use. So yeah, this is another thing that I wanted to talk about. We know about these naming mechanisms, for example, v1 alpha 1, v1 alpha 2, and v1 beta 1, and then eventually v1. So it simply means that how mature that particular API resource is. If it's in alpha phases, it simply means that it's not enabled by default. Administrators will have to enable it. The support can go away at any time. If it's beta, it simply means that it's enabled, but it's not mature yet. And if its version is v1, in that case it simply means that the resource, the endpoint, or the endpoint resource is mature and can be used on production instances. So yeah, I think this was pretty much it that I wanted to talk about. This is the first video in this series where we would be exploring client Go to write Kubernetes native applications. And in the consequent videos, we are going to dig deeper into client Go. So this was pretty much it. If you liked the videos, maybe you should consider and consider liking and subscribing to the channel. If you have any question, I do answer every question on my on the comments section. So if you have any question, don't hesitate to ask them in the comment section. I'll see you in the next one. Thank you so much.